This quiz question tests your understanding of MiniBatchKmeans, a scikit-learn clustering algorithm. I want you to identify why its results might be inconsistent across multiple runs, even with a fixed random state. This statement is correct. MiniBatchKmeans works with small data chunks, mini-batches, not the whole dataset at once. The order in which it processes these batches randomly affects its final outcome. Think of it like shuffling a deck of cards and dealing. Every shuffle gives you a different order. The algorithm's iterative updates of centroids, the center points of clusters, are sensitive to this randomness. This statement is incorrect. Deterministic means always producing the same output for the same input. MiniBatchKmeans is not deterministic because of its use of mini-batches, introducing inherent randomness. It's not a coding error. Correct. The _random_state parameter only controls the initial random positions of the centroids, not the entire process. Each mini-batch update still introduces randomness. Incorrect. Increasing the batch size reduces randomness because more data influences each centroid update. However, it won't entirely eliminate randomness unless the batch size becomes as large as the whole dataset. Then it's not a mini-batch algorithm anymore. This is the core problem we need to solve. The inconsistency in MiniBatchKmeans results boils down to its stochastic nature, introduced by the mini-batch processing method. I see that the question focuses on why MiniBatchKmeans, a clustering algorithm, sometimes gives different results even when using the same random starting point. It's all about understanding the algorithm's random nature. We are trying to figure out why MiniBatchKmeans gives inconsistent clustering results. This means the clusters found in one run might be different from clusters found in another run, even if we use the same random seed. I think the _random_state parameter only sets the initial positions of the cluster centers. After that, the algorithm updates center locations iteratively based on small portions of the data, introducing randomness. So, the initial setup is fixed, but the rest of the process is random. I'm focusing on the fact that the algorithm uses mini-batches, small portions, of the data at each step. The order in which these mini-batches are processed affects the final positions of the cluster centers. It's a bit like shuffling a deck of cards. You'll get a different order each time even if you use the same shuffling technique. This title introduces the core problem: understanding why the results from scikit-learn's MiniBatchKmeans algorithm are inconsistent, even when using the same random state. I will analyze why this happens. This section delves into the algorithm itself. I'll focus on its key properties, especially its stochastic nature, to understand the root cause of the inconsistency. I'll explain why it's faster but less precise than the standard K-means algorithm. I'm examining the inconsistent clustering results obtained using the MiniBatchKmeans function from the scikit-learn library. I'll explore multiple possible reasons for the inconsistent behavior. The goal is to figure out which explanations are valid. Here's the core quiz question. We're troubleshooting why repeated runs of the MiniBatchKmeans algorithm on the same dataset yield different results. Even when using a fixed random seed, _random_state, the algorithm's inherent properties cause the inconsistencies. A visual representation of the algorithm's steps would enhance understanding, clarifying how the algorithm processes data iteratively using mini-batches. I'll explain how different batch ordering causes stochasticity. I'm looking at the inconsistencies we see in the results of MiniBatchKmeans, even when using the same random state. This is a common issue, so let's dive into why this happens. This statement is correct. MiniBatchKmeans is stochastic, which means it uses random sampling in its calculations. This random element causes changes in the final outcome even if the initial parameters, random state, are identical. Think of it like this. If you shuffle a deck of cards and deal the top card multiple times, you won't always get the same card. That's what makes it non-deterministic. The order in which the algorithm processes data points directly influences the results. Absolutely. The _random_state parameter only affects the very beginning. It sets the initial starting points for the cluster centers, centroids. But after that, the algorithm's iterative nature and the use of mini-batches, small portions of the data at a time, introduce randomness to the centroid updates. Each update depends on the batch that's currently being processed, and this process is inherently random. This is incorrect. MiniBatchKMeans is not deterministic. It's the opposite. Its stochastic nature is part of its design. Inconsistent results are expected, and you shouldn't assume a bug exists unless you can rule out this randomness. Increasing the batch size reduces the randomness, yes, but it doesn't eliminate it. To get perfectly consistent results, the batch size would have to equal the size of the whole dataset. It would essentially become the standard K-means algorithm at that point. Think of it like this: a larger batch is like taking a more accurate sample. But there is still inherent randomness in sampling. I'll use this to summarize the core problem. Even when you keep the random state constant, running MiniBatchKMeans repeatedly on the same data gives different results. This directly illustrates why option A and C are correct answers. This indicates that more than one option from the choices provided correctly explains the observed inconsistency in MiniBatchKMeans' results. And, as we've seen, options A and C fit the description perfectly. The final answer is A and C because of the reasons explained in the previous sections. The stochastic nature of MiniBatchKMeans and the fact that the random state only affects the initial conditions, not the entire process, make those the right answers. This section introduces the core problem. Understanding why scikit-learn's MiniBatchKMeans algorithm, designed for fast clustering of large datasets, produces inconsistent results even when using the same random seed. I'll explore the reasons behind this behavior. This is the actual multiple-choice question about the inconsistency of MiniBatchKMeans. I'll analyze each option to determine which explanations accurately reflect the algorithm's stochastic nature. This statement is correct. MiniBatchKMeans works with small subsets of the data, mini-batches, at each step. The order in which these mini-batches are processed influences the final cluster centroids. Think of it like this: if you build a Lego castle piece by piece, the order you add the pieces matters, even if you use the same pieces each time. Each mini-batch is a piece, and their processing order affects the final result. This statement is wrong. MiniBatchKMeans is fundamentally stochastic, meaning its results vary across multiple runs, even with the same settings. It's not a bug, it's a feature of its design for speed. It's like shuffling a deck of cards. Even if you shuffle in the same way, you won't always get the same order. This option is also correct. The randomstate parameter merely sets the initial position of the cluster centers. However, the iterative process of updating these centers based on mini-batches remains random. It's like setting the starting point of a random walk. The walk itself is still random. This statement is incorrect. Increasing the BATCHSIZE reduces the randomness but doesn't eliminate it completely. It's like making a larger Lego castle piece by piece. You have fewer steps and the randomness has reduced, but it is still not deterministic. I'm going to explain the MiniBatchKMeans algorithm. It's a clever way to speed up the K-means clustering method, which you use to group similar data points together. Instead of using all your data points at once, which can be slow for massive datasets, MiniBatchKMeans works with small random chunks, or mini-batches, of data. This makes it much faster. The trade-off is that the results might not be perfectly precise every time, hence the inherent stochasticity. In this algorithm, you're using the MiniBatchKMeans algorithm from the scikit-learn library to cluster your data. You've noticed some quirks. The clusters are different each time you run the code, even when you use the same _random_state setting. This brings us to the core problem we will analyze. The _random_state parameter sets the initial random seed, kind of like shuffling cards before dealing them. It only affects the very first step of the algorithm, the placement of the initial cluster centers. However, because MiniBatchKMeans uses those mini-batches, there's still randomness in how the algorithm works after the first step. Think of it as shuffling the deck again in later stages of a game. Therefore, I emphasize that the _random_state parameter does not ensure the same result in every run. I'm going to clear up a misconception. MiniBatchKMeans is not inherently deterministic. Deterministic means that if you start with the same input, you will always get the same output. MiniBatchKMeans' use of mini-batches and iterative updates means it is not perfectly deterministic. Increasing the _batch_size parameter does help. A bigger batch size means you're using a larger chunk of data in each step. That makes the algorithm less random. It's like shuffling a smaller deck of cards repeatedly. The effect of shuffling each time will be less than shuffling the whole big deck. But it won't completely remove the randomness unless your batch size becomes equal to the total size of the data, essentially making it regular k-means. This is the overall theme. Why do I get different clustering results when using MiniBatchKMeans even when I try to control randomness? This question will lead us to the understanding of the algorithm's stochastic behavior. This line simply introduces the quiz question we will analyze. This line introduces the context of using MiniBatchKMeans from the Sklearn library and highlights the core problem of inconsistent results despite using a fixed random state. I see mini-batch processing as a way to speed up k-means clustering. Instead of using the entire dataset at once, I'll process it in smaller, manageable chunks or batches. This makes the computation faster, but it introduces randomness, which could affect the final results. Think of it like assembling a really huge Lego castle. Instead of working with all the bricks simultaneously, I work with a handful at a time. This will be much faster, but the final structure may not be exactly identical every time because of the random selection of the bricks. That's the trade-off, speed versus absolute consistency. Stochastic optimization means I'm using a method where randomness is inherent to the process. Each step toward a solution involves an element of chance. For example, in MiniBatchKMeans, the order in which the mini batches of data are processed impacts the final clustering result. This means that every time I run the algorithm, I'll likely get slightly different results, even with the same starting point. It is like navigating a maze. Each path might lead to the end, but different paths will take different amounts of time. This statement directly reflects the stochastic nature of MiniBatchKMeans. The order of data points in mini-batches impacts the final centroid locations because the algorithm iteratively updates centroids based on the data in each batch. This makes it similar to a coin toss. You don't know if you will get heads or tails until you actually toss the coin. Similarly, the centroid will be different based on the ordering of data points and the sequence of batches used. I disagree with this statement. MiniBatchKMeans uses stochastic optimization, hence is not deterministic. Inconsistent results are not necessarily bugs, it's a characteristic of the algorithm. It's like baking a cake. Different batches of flour might produce slight variations. I'll explain it in this way. _random_state acts like a starting point. I set the initial centroids using a seed. However, as MiniBatchKMeans proceeds, the iterative nature of updating centroids from mini-batches creates randomness. Think of it as rolling dice. The initial roll can be fixed, but the following rolls are independent and random. I find this statement is partially true. While increasing the batch size reduces randomness by including more data in each iteration, it doesn't eliminate it completely. It's like drawing a larger sample from a population. This sample is more representative, but still might not perfectly represent the entire population. Only when the batch size equals the entire dataset will results be fully consistent, but that defeats the purpose of using MiniBatchKMeans in the first place. This simply describes the problem of inconsistent results from running MiniBatchKMeans multiple times, even with the same random state. This happens because the algorithm uses mini batches of data and is inherently stochastic. This sets the stage. I'm using MiniBatchKMeans to cluster data, and I'm seeing inconsistent results. The question aims to find the reasons behind this inconsistency. Already explained above,